6 minutes long, the API call that you make from whatever. Okay? Whether it's you're using a PowerShell client, whatever, you have to have some type of digital signing of that API. At AWS, anything you do outside of the cloud programmatically has to be digitally signed. Okay? Now, when I say digitally signed, you may not know what that means. Okay? Here's what it means. I go and I set up I'm going to show you in a minute here, but I set up the CLI. So I can do the AWS CLI, or maybe it's the Google Cloud SDK, which has a command line tool. Either way, okay? I'm making programmatic access. Eventually, once I configure this, I'm going to be coming in here and issuing commands. These commands, this is the input that goes into a cryptographic hash, a one-way mathematical function, like SHA-2. It's irreversible. So the API that I type gets hashed. And then it's going to generate a fingerprint, like a 256 strings of characters, a digest, a fingerprint, or whatever. Then I have an access key that was given to me by an administrator or myself. And that key, I'm going to derive a session key from that key. And that session key that's derived will be used to encrypt or sign this digital signet, this hash function. So this gets re-encrypted or signed. So this gets applied or attached to the API call, and I have 15 minutes to send that up to the cloud. Okay? So notice when I'm digitally signing something, I'm not encrypting the API call. I hashed it, and then I encrypted the hash, and then I attached it to the API. So remember, that's not confidentiality. If I want confidentiality, I'm going to use like Secure Shell 2, TLS, that IPsec, something that provides confidentiality. So let's say that I want the user to be a programmatic user at AWS. Okay, AWS. Let's go take a look at the, I don't want to do that yet. Here's what's going to happen. That VNet that we call it, AWS calls it a VPC, a virtual private cloud, but that virtual network from an IP version 4 standpoint, okay, the IP address, it's going to be something private, okay, 10 dot something, 172.16, 172.31, 192.168, something that is private that's only used behind an edge device, not addresses that are not legal on the internet. If you want to expose something that you deploy in a public subnet, it will have to translate in one of several ways to a publicly legal routable address, IP version 4. All of your virtual networks in the cloud are expressed with CIDR or CEDR, okay, classless interdomain routing. See, way back in the day, and I taught a class earlier this week on Wednesday, I taught TCP/IP fundamentals. And one of the things I talked to them about was early on in the early ARPANET, the early days of the internet, they broke up those addresses. So it was a finite amount of addresses because it's a 32-bit address, 32 zeros and ones separated by dots, and then you express them with decimals, 192.168.100.13. Back then, though, they created classes. So it was kind of like on a luxury airliner. You had first class, okay, that was the early adopters. They got the class A addresses. There weren't a whole lot of those, but each one of those had millions of host addresses. Then the next group, business class, class B, the Johnny-come-latelys, the Microsofts, the Novells, there was more of those networks, but each one of those networks only got 65,000 hosts, which was still quite a bit. C, coach, okay? Those are the ones that like the small individuals and small businesses. So there was millions of those, but each class C only had 254 addresses. And then class D was for multicast, and I'm multicasting to you right now, okay? Multicast, and then E was experimental. So we don't use that class system anymore. We use a classless system. So basically what we say is we have an IP address, 172.31.0.0. We put a slash, and then we put a number after it. And that number means starting with the high order or the leftmost bit of the 32 bits, how many of them are the network part of it, and what's the host, how many bits for the host on that network. It's like saying, hey, where do you live? Well, I live on Main Street. That's not going to help me. That's your network. Okay, I need to know your address on that network. So all of the virtual networks of the cloud providers, it's a /16, which means that network has 65,530 something hosts. Okay, can you take that network and just have one giant /16 network? You could, but you're not gonna. You're gonna divide up that address space and do subnetworks. Now, that's beyond the scope of this. I just taught AWS Networking Essentials yesterday. I would love to see you in my next AWS Network Essentials course, but, okay. The other part of networking, besides you emulating maybe some local area network or using the virtual network for some other purpose, is the content distribution networking, right? Where you create a website at the cloud and you want to get your content as close to your customer as possible in Germany or South Africa or Japan. Cloud distribution networking, okay? So networking really has kind of two pieces. You could never use your own virtual network and just use content delivery networking or content distribution networking. That's all you're going to do. Create your web apps, distribute them globally. Or you may use your virtual network maybe to deploy your data warehousing in so you can do business analytics against it. But the first decision that you're going to make, because if we look at the model of networking, where you have a physical layer, what type of cabling are we wired? Are we wireless? Is it fiber? Is it Ethernet? And then the switches, that doesn't matter to you. As a customer, everything begins at what we call the network layer, layer 3. So really your first decisions you're going to make on the virtual network is what kind of networks are they going to be? And there's three kinds, okay? There's a public network, which means whatever you put in it, instances of Mac OS or Linux or Windows or some virtual router or virtual firewall, whatever you deploy, whatever you instantiate or spin up, we say, into that subnet, if it's public, it means it has some type of gateway that it's going through to get to the internet, and vice versa. You're exposing these instances of whatever to the internet. That's a public subnet. That's one kind of subnet. Another kind of subnet is a subnet that you use because it's part of a VPN. It's an extension of a virtual private network from your headquarters or a regional branch office or whatever. So this subnet is using some type of VPN gateway, and it's connecting to some device at your headquarters or a regional branch office, or maybe even a teleworker's site or home. It's a VPN subnet. The third type of subnet is private. There's no way to get to these instances over the internet, and there's no way to get to these instances through a VPN connection. So it's a sandbox. It's a private subnet. You can access it, technically speaking, through the back end, but you're not accessing it over the internet or through a VPN. It's a private subnet. Yeah, GR, it's a really good question, and I'll explain that in a minute. That's going to involve what we call elastic load balancers. Okay, but I'm trying to keep this a real simple discussion because I got to talk about 3 other core services today, but I will mention that. Okay. So, by the way, the network design, usually at a cloud provider, you're not doing this from scratch. You're going to do like an infrastructure as code thing where they'll give you like options, and as you choose options, they'll give you a visualization, kind of like what I showed you earlier with the cloud formation. So yes, as an individual, you could go up and you could, mess around with your virtual network by default and mess around with it. But usually they're going to give you some templates and say, here's a use case. Do you want to use this template? That's more likely what's being done. Now, what I did, and this comes from a couple of other AWS live courses that I do for O'Reilly. Okay, and it says Pearson down there, but that's Pearson's O'Reilly's part. It had to be different. But the thing is, these components over here are pretty universal. They may be named something differently, but they're pretty universal. Okay, so what I did is I put a series of slides in here for you as a reference, because I'm not going to really teach all this, but as a reference, okay, to understand what each one of those components is. So you'll see a slide that says, what is a virtual private cloud or what's a virtual network? Okay, what's a subnet? A subnet is a VLAN. Okay, what's a route table? It's a set of rules to determine where the network traffic is directed. So at a cloud provider, the default route table just has one entry. It's basically, how do I get to everything else in this virtual network? So it'll be like local traffic is 10.10.0.0/16. That's all that's in there. And then it's up to you to go and put in routes to other things. Gateways, for example. Okay? Route tables. An internet gateway is the component that the cloud provider offers for your public subnet to get to the internet and vice versa. Okay? The internet gateway, for us, we want to look at this right here. Because as I mentioned, remember, by default, your virtual networks that you get, they're going to be private addresses. Private addresses. Okay? So if it's in a public subnet, something has to translate that to a public address or do network address translation. It's this gateway that does that. Okay? Now there's a couple of ways to get public addresses. You can tell the cloud provider, look, when I run this instance of Windows, just automatically assign me a public address from your pool. Okay, just auto assign it to me. Now, if I stop the Windows server, if I shut it down, I'm going to lose the address. And the next time I run it again, give me another address from your pool. and the gateway will translate to that address. Okay, that's something that you can do. Another thing you could do, you can say, here's my account, and in my account, I want you to allocate to me my own addresses, my own public addresses. Okay, you're going to allocate these to me, and then I can, under my control, I can associate them with an instance of Windows or Linux or whatever. Now, if I shut down or stop it from running the instance, that instance is no longer using that IP address, but it's still my address. It's allocated to me. Usually, by the way, if you do that and you don't use the address, they charge you for it. Okay? That's a couple of ways for an instance in a public subnet to get a public address. Okay? If it's in a private subnet, you don't need one. Okay? What else do I want to talk about here? So that's the elastic IP thing. The elastic IP is when you go to the cloud provider into this area, the virtual network area, and say, hey, give me a public address. And I want to use it, and I want to associate it. I want to have control over it. Okay? Now, when I showed you this diagram early on today, remember this one? I think we understand pretty much everything like here. You know, we know that there's 4, maybe 5 foundational services. Azure has machine learning. We understand regions with 3 availability zones and edge locations in metropolitan areas. We know that the data center of the cloud provider, they have their own very high secure identity management. But there's also things called endpoints. And all of the cloud providers offer endpoints. These are virtual interfaces. Okay? Let me give you an idea of how a virtual endpoint would work. Okay? I'll go back to this diagram. All of the cloud providers offer what's called object storage. Okay? We're going to talk about that. These are objects, video files, audio files, graphics, pictures, PDFs, whatever. Blob storage. Usually back-end content, or where you're just storing things short-term or archival, whatever. Okay? So they're in buckets. You have these objects in buckets. At AWS, it's the S3 service, the simple storage service. Okay? Azure is called Azure Blob. Google's called Google Cloud Storage. It's object storage. There's no file systems. Okay? There's no hierarchy. But there's 2 ways to access these buckets. Now, for the original way and the only way you had for years, whether it was somebody outside of the cloud, was to use, a URL that you would they would provide you with a URL, or you could use your own domain name. I could do the same thing. I could go, let's say this is a public subnet. I could log on to this Windows server, right? Bring up my Edge browser. Okay, I can't use IE anymore, but bring up my Edge browser, and in the browser, in the address bar, maybe some other page, put in or click on a hyperlink that's the URL to this bucket. And I would go to the gateway with my private address, get a public address, and then go out and access this bucket. That's how things were done at cloud providers originally. And you can still do that. That isn't the only way. Another way for me to access that bucket is to do it with an endpoint or a virtual interface. Here's what happens there. At the hypervisor, because these are all running in hypervisors, okay? When I brought up this instance of Linux or Windows, it had a virtual network interface. A virtual Ethernet card, right? Ethernet 0. It's virtual. And it gets a logical MAC address. 48 bits expressed in hexadecimal. So I get one of those, right? I have to have that on my instance of whatever so I can communicate with other instances in my subnet or other subnets in my network or whatever. So what the endpoint or the virtual interface thing does is this. I don't want to go to this S3 bucket and the objects. I don't want to use a URL. I want to use an endpoint. And so I tell the cloud provider, I want to use an endpoint to get to this bucket. This bucket of pictures of Michael Shannon's LP collection, vinyl collection. So what it does is, okay, I'm going to create a new logical virtual network interface. In fact, it'll be Ethernet 1, because Ethernet 0 was the first one. So we'll create a new virtual network interface, take the next available private IP address in that subnet, assign that to your interface, and that will be used over the AWS cloud to access the bucket. And all of the cloud providers offer these virtual endpoints to access all of their services over the cloud. They all offer the same type of connectivity, these endpoints, okay? They don't always call them the same thing, but it's just you're making an API call, okay? An API call to that service. And usually, not every new service maybe doesn't support the endpoints yet, but eventually they'll support the endpoints or the virtual interfaces. Maybe it depends on what region of the world you're in. Those are very important aspects. Another important aspect in the cloud is peering, because you might want to have hosts or instances in one VPC, we'll say VPC A, to be able to send and receive or communicate with another VPC. Now, I don't mean within the virtual network. I mean from one network to another. Okay, so this would be virtual network B, VNet A, VNet B. That's a peering relationship. It's a two-way peering relationship between these two virtual networks. Now, here's the deal. If you have administrative permissions over both of those virtual networks, and they could even be in different regions, but if you have an administrative permission, you can be the person that requests the connection, you request it to peer, and you accept it. Okay? As long as you have administrative permission to do that, you can request from A and you can say, B, I accept. And you have a peering relationship. But if you want to peer with another VNet or VPC, and it's not within your administrative domain, it's not in an account that you have permissions, somebody from that account who has permissions has to accept the request. You just can't go peering with anybody out there, okay? But that's another thing that's been commonly done for years, peering between virtual networks. Okay. Earlier I mentioned that today, when you go and you follow a hyperlink, if you were to use a tool like traceroute or a trace tool, and you traced the hops over the internet, more often than not, when you get that page or that content, you're getting it from a content distribution or delivery network. Remember? Akamai, no, GR. The peering subnets cannot share the same address range. Okay? They have to, one of them, so I'm getting it too advanced here, but at AWS, the answer is no. One of them would have to change the IP address, or they would use something, a new thing at AWS called a transit gateway. It's kind of a virtual router hub. And on that transit gateway, you would basically do what's called bidirectional NAT. Sorry, that's advanced. But your question, no, they can't share. Okay. Another question that comes up, okay, along that same line. So let's say here's your headquarters, and you have your own, maybe you're using addresses that are public, or you're using some address range that's private but that you want to use. In your VPN subnet, what if you want to use the same address space in your VPN subnet? It might even be a public one. Can you do that? Yes, but only in the VPN subnet. Not in a public subnet, not in a private subnet. Only in that circumstance could you use the same address space, even a public address space that your headquarters or regional office is using. Okay, so remember I mentioned that usually you're going to go today to a Akamai or Cloudflare, something like that. The other likely place you would go to is a company who is servicing customers at a cloud provider, and they deploy what's called an application elastic load balancer. Okay? They deploy this elastic load balancer thing, which is, we call it horizontally scalable. You can't overwhelm it. It's a part of the cloud, and they'll just create new nodes, okay? But it's an elastic load balancer that's processing, eventually, always HTTPS traffic, and then running some type of listener service or certificate service on it that may need to decrypt it. But the point is, elastic load balancing is very popular. So you'll deploy these load balancers out in front of your virtual networks with your public resources. And when somebody types in the name of your website, they're going to an elastic load balancer. And what that elastic load balancer is often doing is it is connected to what's called a target autoscaling group. What is that? Well, it's a subnet of instances that are automatically scaling, right? So these are Nginx servers. They could be containers. They could be IIS servers, Apache servers, whatever. So the load balancer, this is what people are coming to when they put in your domain name or your IP address. And then you've got all these front-end web servers that are auto-scaling. So what you've done is you've got this template that you've used to determine how that group is going to scale up. And like they'll instantiate new servers within minutes as needed. So usually in this kind of template you set up, the first thing you're going to do is where do I begin? What's the baseline? Okay, 20 Apache servers, right? What's the baseline? And then you would say, okay, but I don't ever want to run anything less than 8. So I'm always going to run 8 Apache servers in that subnet behind the load balancer, okay? And then you would determine how you scale out. And this can be done with a couple of ways. One would be, I want to do it deterministically. So you've kind of analyzed the traffic and you realize that most of my traffic is Monday through Friday. So it deterministically means I'm going to set up a schedule, right? I'm going to scale up on Monday morning, scaled back on Friday evening, or vice versa. I'm busy on weekends. So deterministically, you schedule it. The other is like as needed, okay? So you get a lot of volume, you'll keep scaling up, but you'll have some limit. At some point, the cost-benefit analysis, the return on investment kicks in. You go beyond 100 instances, I'm going to start losing money. So it could be just dynamically, okay? Dynamically. Now, all cloud providers today offer a way to directly connect. In other words, you make a device at some site part of the cloud provider's internet. Okay? So at AWS, it's called Direct Connect. Okay? At Google, it's called Google Interconnect. At Azure, it's called Express Route or Express Route. Here's how it works. And I'll use Houston for an example, because I lived there 3 months ago. In Houston, I had my entity, say my business. I had 3 different options that I could have a fiber connection to in Houston, and that business would create for me a customer cage with a virtual router in it. Okay? Now, AWS, IBM, Azure, Google, they already have a cage with their highly available virtual routers there. Okay? So, like in Houston or Chicago, I can say I want 1 gigabit per second, I want 5, 10, 50, sometimes up to 100. Like Chicago, Columbus, Ohio, 100 gigabit per second from my edge device across this provider to AWS, either with a private endpoint connection, or VIF they call it, or a public one to all their other services that are running. This is very popular. This is what we call edge computing, right? A lot of companies, they'll do this with more than one company. They'll have a 50 gig to AWS and Google, multi-cloud, right? From this, highly available router or whatever they're using. Has to support border gateway protocol and this way to tag the frames, but extremely popular, right? And this is how, we kind of get hybrid computing. And we'll talk about it, but they'll like deploy this storage gateway thing. And they'll use this to like get a bunch of data up into object storage or the database migration, or manage their backup and restore over this 100 gigabit pipe. Very popular solution. Now, the other thing that all of them offer, all providers offer a rapid deployed, easy to set up site-to-site VPN. Okay, you just go into the wizard and you tell it a little bit of information about your device, like what's the public IP address, or I generate a certificate at the cloud provider and load it up on my edge device. Okay, but this kind of site-to-site VPN, it's usually like 1.25 or 1.5 gigabit per second. It's not like this direct connect thing, which costs a lot more. Okay, this is just easy to set up. Okay, and the cloud side, which has a virtual VPN gateway, it has pretty much everything turned on. Like for IPsec, it doesn't really matter what your edge device has for its security policy or profile. You're gonna match the cloud in your IPsec policy because they basically are offering everything. It's like lit up like a Christmas tree. So it's just really easy to set up. Okay, really easy to set up. But like the direct connect or express route, the only dynamic routing protocol that you use in this situation is border gateway protocol. Okay, border gateway protocol. Whether it be the direct connect, express route thing up to 100 gigabit per second, or your site-to-site VPN. Now, if your question is, what if I have an existing VPN cloud and I want to use something else like OSPF or dynamic multi-point VPN with EIGRP or Get VPN, whatever. You can do it, okay? You can do it, but what you're going to do is in a public VNet, a public subnet, you're going to deploy like a virtual Cisco router